here again. And here with me is Kata and Diane from Syntaxia. We're going to just have a quick conversation about AI and how to think with AI. So, in a way, uh, AI changed the game. So, historically, and for decades, we've been thinking about systems in a way that they are deterministic. You do this, you get that. And we've written our programming languages, our user interfaces, our programming interfaces in a way that they are deterministic. AI changed that. They are more probabilistic and they are trying to predict what's the next best outcome based on this input. And that paradigm shift is really interesting to think about. So to
Yep.
use, yeah, go ahead, Diane.
Well, I was actually just thinking that that's a powerful shift, And so you're saying that we're no longer telling the system what to do, but we are working with it.
That's true. So, specifically with the LLM based systems for the past 2.5 years, uh, the models that exist right now are exposing a different way of thinking. You are working with them, you're giving them a question, and they are giving you the next best answer based on what they know. So, we humans, we think in a way that is based on years of experience, based on years of knowledge that we have. So, we kind of know more, but these LLM systems know what they know, and they are thinking probabilistically. So, what seems to us as cognitive knowledge or intelligence is more based on probabilistic model fundamentally. So I would think of with about AI as an alien intelligence, and that really rewards thoughtful ambiguity. Meaning, if you ask it a question, it will answer only that question based on what it knows. So if you give it a little bit of color, saying instead of help me write this email better, which is very vague, it doesn't really know what better is. It's going to give you some kind of a best estimate of what that better word means or what those words mean. You give it a little bit more of context, not very deterministic in terms of the context, but a little bit like ambiguous, meaning, help me write this email to someone who needs to be, let's say, more influenced to understand more this topic X, and then the outcome that I'm looking for is Y, and then these LLM systems will give you a probabilistic answer based on what they know is more interesting to you. And this is how we can get to some outcome. And again, this is really based on what users use or interact with LLM. So it's not really for systems, and we can talk about that later.
That's actually sorry, but also it's kind of scary when we think more about critical systems, as you say. So, how do
Mm.
you reconcile that probabilistic nature of AI with domains that require precision?
Right. So that's really the tension, right? So it's a it's a paradigm shift in a way. There's a big tension between the systems that we used to develop and we are still developing to this day that are more deterministic, and these probabilistic aliens that we're trying to incorporate. And I think the right way is to understand how to interact with them. I think in a recent article we wrote is, uh, y- first of all, you need to think in a way where your questions, your prompts, as everyone understand, are a little bit nuanced, but you need to think that the model is more iterative. So the first question you ask with the most context you have will give you, the LLM will give you an answer based on what it knows, so what it was trained on, what it has access to. Like some of these models have access to internet or could actually connect to different systems using the protocols of communication that they have, and give you an answer. Rarely the first answer is the best answer. It will give you some output, and eventually you need to ask another question to refine it and go drill deeper into what you want and what you want to have. So in that, if we think through these AI systems that way, so first they are iterative, Second, they reward thoughtful ambiguity. You you will find like systems that are built on playbooks of multiple prompts that are sequenced, and that will get us to the desired outcome we want. And again, that outcome might not be deterministic, meaning if we ask the same question again, or the same question with a different context again, we will get a different output. That's the tension. Traditionally, in systems, if you ask the same question, you will always get the same answer. They are more functional, they are predictable. Think of banking system, think of a airline booking system, any of those sorts. Like that information you get on the interface using those buttons that you click on, and this is like a search and then a submit, you will always get the outcome you want. With AI, we need to think about them differently. I hope I answered the question. So, but it's interesting. Like this is really the paradigm shift we're seeing here, and the way to interact with them is different as well. Like, and it's evolving. 2 years ago, it was just one prompt. Okay, good. And then over time, you figured that you need to find different prompts. Now, with the introduction of the reasoning models or the inference model, we have actually a different way of interacting with these systems or designing systems. Actually, one trick we found interesting is by having these playbooks of different prompts, right? So prompt one, a set of prompts will give you a certain task with one, let's say, context of an agent. That could be a traditional LLM agent or an SLM agent or SLM-based agent. You could use an inference reasoning model to check the output of that agent against some kind of a baseline and then do some action. So we now thinking about designing systems that incorporate these probabilistic agents or AIs in a way that would potentially provide more of a deterministic answer that we are familiar with and that we humans would like in our systems.
Quentin, I just want to go back to what you mentioned earlier. You mentioned protocols, right?
Yeah,
So can you unpack that a bit? Like, what do you mean by that in the AI space?
that's a good question. The protocols are frameworks that allows us to organize communication between different components of the environment. So traditionally in the internet, we have one protocol that's very famous. TCP/IP was the protocol that everyone on the internet building systems has used to communicate between components in the network. In the mobile world, we have GSM, which is a framework of or a set of protocols that allow for mobile communication across like continents, across devices. And now we are finding that these agents needs to communicate with different systems as well, right? So if you're building uh, um, these prompts using LLM, you need to potentially communicate with other systems that they could be a database, they could be a file on a server, or they could be another agent in a way. Like there's a prompt that you need to ask again. What we found is that there needs to be a guiding protocol that allows these agents to access or communicate with the other systems. You could do it by prompting, which lead us to a situation where, let's say, making it very simple and blunt, we're using OpenAI GPT to communicate with our database that's on this site, and then another ERP system or a CRM, right? So APIs. We build our system so that we make it understand what are the interfaces of those two systems, the database and the CRM. It could be an API, or it could be direct access through SDK to the database. The issue here is that with more agents you add, you need to replicate that knowledge of how they communicate with those systems. And this problem was first initially solved, or at least there was a proposed solution by Anthropic. So back in December of last year, they announced the Model Context Protocol, MCP. Do we have a slide of this? I think we have something we can show up on screen about MCP. Right, so this one that I have here. So before having this protocol of communication between the agents and the systems, you had to have a one-to-one relationship between the agent and how to communicate with that system. Adding more agents means that you need to replicate that definition of how to communicate with those systems. MCP, or Anthropic protocol here, allows us to create one unique protocol to communicate with these systems, the target systems, and the agent will basically interact with MCP, which is a nice, elegant solution that allows us to have a unified way to communicate between these systems. Again, protocol is just a way to communicate between different systems, and there are different proposed solutions for it. Anthropic proposed MCP. Google this year, they announced A2A, which is a protocol of communication between agents. I think we have another slide for this. Let me show you. Yeah, this one. So here, if you have two agents communicating between each other, we need to organize that communication. So the proposed protocol of communication here by Google, A2A, which is being adopted by various providers right now. So Microsoft started adopting this earlier this month. This basically allows these agents to follow that structure, that flow, to ensure that we have a clear communication. One system understands or constructs the request in a way that the other system understands it. So when we get the request, the system knows how to react to it and sends back the response. So things are actually organized. These protocols are fundamental in the engineering of the new systems that we're building nowadays. And again, we are in the early age of how these things work. One thing interesting, let me think about this, is that how would you combine these? Like in a real world, you would have maybe different agents. Those agents are communicating with systems that are on site, like an ERP system or a database. So for that, they would use MCP. And to communicate between each other, they use this protocol A2A. And then the underlying transport layer of communication is probably using TCP/IP and at the low level. So all of this is just organizing these protocols of communications between these new systems that we're building. So MCP, A2A, A2P is another one. All of those are protocols of communication that organize how we are building these systems nowadays.
Okay, Quentin, so I believe that the better way to understand all these protocols and all these systems is by saying or understand making the audience understand how your own company, how Syntaxia approaches it. So how does that show up in your work at Syntaxia?
It's a good question. So in client work and internal products we're building, we're not exposing these LLMs by themselves. Like there are, like I shared a little bit of a technique that we use, and that seems to be interesting. And again, these things are evolving, where we combine the deterministic aspect of the software or the solution with the probabilistic aspect of the LLM. So the LLM allows us to maybe have a good digest of information that is very broad, very hard to access, so valuable set of data. In the absence of having a semantic layer, which is very critical in these systems, and I think that's probably the next best thing, is to have a semantic layer that organizes the knowledge of the domain, that makes it presentable and digestible by the AI. The LLM now, when the LLM-based agent, when presented with a prompt, know how to access certain information using those protocol of communication we shared earlier, but also knowing what kind of a concepts, what kind of a relation it needs to access first from the semantic layer. But then it's iterative. So we do multiple prompts to get one output. We validate that output against another agent that basically has a baseline, or maybe the input that we expect, or a similar input and output that we did before, and it validates the output of that agent. If the response is correct, we move forward. If the response is not correct, we do that loop again. And since these systems are probabilistic, most of the time we will get the proper output in the second or third iteration. This makes them a little bit expensive to build and to run, which is in the grand scheme of things, and this economic world, it's still not probably the best way to do them. And actually, it's not the best way, I would say, to solve certain problems. For instance, what Klarna did in the past few days is they announced that they removed completely the AI bots from their support system. They could potentially, if you think about it, have much more sophisticated agents that could be much more expensive to run, or maybe longer in terms of taking time to respond than a human, but they could answer the question. The issue is that they could be very expensive, and second, they are not as fast as a human to answer the support question from the users. So they just ditched the AI-based approach for now, and then they reverted back to using their traditional approach that involves the human in the loop.
This is all very, very interesting and insightful, Quentin. I'm asking. I'm wondering, after hearing about all of these technical shifts, I'm wondering if there's like some key reflection or insight that we shouldn't overlook, like from now on, regarding how we think with AI.
Maybe one way to think about it is that they are allowing us to rethink our business model in general. Like, instead of saying, how can I automate this process using AI, you would probably rethink entirely that question. One question that could be interesting: if I was not that company trying to automate that process, how would another company that would use AI solve this problem going forward? So it's really trying to rethink the value proposition and how we achieve that value to customers, instead of taking small components and automating them with AI. And I think that's the right approach. We're seeing it with one client right now. And I think they're asking the right question. They are rethinking the whole entire enterprise system that they provide by rethinking their approach. So now we're building a semantic layer for the whole domain ontology that is accessible to by AI systems, but also by deterministic algorithms on top of it, and it makes it much more cleaner and faster to answer correct answers. The other thing is, again, think of them as allowing you to think with you, with the context that they have. They are not mimicking our way of answering properly. So they are more of an alien intelligence. They are not a human intelligence. Artificial intelligence is the right word. But I'd like to think of AI as more of an alien intelligence rather than an artificial intelligence, because this way it kind of there's a machine, there's an alien, and there's the human, and they are all think differently. The machine thinks in a deterministic way. The alien thinks in a probabilistic way based on what it knows, and the human thinks in a very probabilistic and in some cases formal way based on what it knows, but it expects a deterministic answer. So this is a way to approach any problems we're solving right now using AI.
Okay. Um,
Go ahead.
can we break this down a little bit? So since you talked about protocols earlier, like A2A and A2P, in layman's terms, for someone who's never heard of that, what's a real world example for this?
I would say a protocol of communication is similar to what we're doing right now. You're asking a question in English. I understand the question. I think about it and I give you an answer. If the answer is correct, you continue asking. You move on, or you ask me another question. The communication here, the protocol of communication is there's a requester, there's a responder, and there's what do you call it? An agreed upon language of asking the question. In this case, we're using English. You ask the question in a formal way, so we know that's a question, and then I know that's how to answer it. So it's more of a organizing how things actually work between different components of the system. And this is probably interesting because we heard from a client before, like, hey, let's use MCP in our architecture. Not knowing that MCP is just really a protocol of communication can create a lot of confusion. It's really interesting to understand that MCP is a protocol of communication. An agent is really just a set of prompts that are used to interact with LLM, and that runs on a batch process, or runs on a scheduled process, meaning that's what a batch process is. And you're just running those agents or LLM-based software on a scheduled basis. So trying to understand the components of this architecture, trying to understand how they operate or how they think, that's really the word, is important.
I have one last question regarding, like, going
Okay.
back to what I asked before. Say I'm a founder. How do I start? And what mistakes do people make, like used to make when they first start using AI?
I think the first question is that they expect that these systems are deterministic. That's going to be surprising to them, that they are not really deterministic. Having the right information available for these LLM-based systems is very important. So cleaning your house, making sure your data is in order, making sure that you have maybe semantic layer in place if you have a lot of data, like a large data model and different data sources and so on, is very important, because that makes the information easily accessible to the LLM-based system. But also they understand these are the concepts that I have in my domain. This is how they relate to each other. These are the constraints that are important and relevant in this data domain. And when you ask the prompt, they would know how to answer it based on the data model that you have and the data domain that you have. But again, they are really probabilistic, so I wouldn't use them in systems that are highly critical and requiring deterministic output without having either a safe guardrails, like following the technique that I shared earlier, where you have different systems actually validating the output, or having the human in the loop. In this case, the other point that probably is interesting is just think about economics. Understand that at the economy of scale, like how the impact of using these LLM system will impact you. And the third thing is we still have to think and write clearly, like the way engineers think, in a formal way, how they write programs in a formal way, in a formal language. We still have to mimic that, even though we are using prompts. So thinking clearly in an iterative way is a key to making these systems work.
Okay, so this has been a really insightful and productive discussion so far. So, for my last question, Quentin, what would you say to someone feeling overwhelmed by all these? So, what can you say for to them for their first step?
Uh, uh, I was gonna say, like, understand the first principles, but then that could also be very overwhelming in terms of where to start and how to start. But you could use actually these LLMs to help you think with you on how to start. So they don't know all the questions that you might ask, but you ask it one question, gives you an answer. Go learn a little bit with it, ask another question, and dive into that, drill down. It's like really, it's like you're sculpting, right? So you have a piece of marble, you have certain prompts. You ask the first question, you get like you chip away a little bit, and then another question, and then you chip away a little bit, and then until you have your final product or your statue. So that same approach I would follow to understand and understand these systems, but also remove all of this confusion. They would help you think better in terms of how you approach these different problems.
All right. Thank you so much for that, Quentin. And I have no further questions from my end. How about you, Kata?
No, no, not at all. I think we're
All right.
right in time. Just thank you for sharing this conversation with us. It's clear that, yeah, the value of AI is in how we use it. So, yeah, thanks a lot, and thank you for making us part of it.
Awesome. Thank you for attending. I mean, we're doing it quickly, 25 minutes, 30 minutes. let's do more interesting questions. Let's hear some questions from the folks who are probably viewing this or attending future sessions or seeing the clips. Just ask questions that will help us also give an interesting perspective on how you think, on how to, and our perspective on how we think about those things. All right, that's all. We'll talk